Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. I request everyone, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now let's read the question. Which one is the starting material for this series of reaction? So here I have given a formula, but you have to say which isomer fits with all these information. So student, this is a very interesting problem. First, I shall explain the product, how the reaction is happening, and after that I'll explain how to get the right answer by back calculation strategy. Okay, so a lot of knowledge will be shared in this video. Now let's start. Now actually student, from there you can understand starting is C8, 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 and this KMnO4, it's called side chain oxidation. So now if you look at here, so there is only one chain, so this part will leave and ultimately it will produce benzoic acid, so that will be C7, so it's a gone. Now in this case all products can result in corresponding carboxylic acid, I mean COH, all cases. Now next is actually bromine iron. By the way, it is aromatic electrophilic substitution and monobromo substitution on only one product. There is a trick. So actually answer is option D here. Okay, let's D. So if I say KMnO4 oxidation, then side chain oxidation, ultimately it will result this dicarboxylic acid. It is called as terephthalic acid. Now these carboxylic acids are student electron withdrawing group. So with respect to one carboxylic acid, the meta position get brominated. Actually this bromine FeBr3, this is also aromatic electrophilic substitution. So with respect to this COH, these two meta, and with respect to another COH, these and these meta. By the way, from this conceptual clarity you can understand any of hydrogen could be shifted. So if you shift any, product is same, so it matches with the condition only one product. Okay, so now if you look at bromine and iron, by the way, for aromatic electrophilic substitution, specifically if I say bromination, and by the way this carboxylic acid is electron withdrawing group, since it is electron withdrawing group, so Lewis acid presence is essential. But here metallic iron is taken. By the way, metallic iron is not at all Lewis acid. So how the Lewis acid is generated? So this bromine is actually an oxidizing agent, halogen, very high electronegative atom, very reactive atom. That's why it reacts with iron and it produces iron 3 bromide. Now why iron 3? Why not iron 2? Remember, compared to iron 2 plus, iron 3 plus oxidation state is more stable, and this bromine is an oxidizing agent. So under this reaction condition, the maximum oxidation state is achieved. And by the way, remember, iron 2 plus is not a that much stable oxidation state. It is very difficult to stabilize. Like few complex you see in a regular basis, for example, iron sulfate, 7 water, green vitriol, or more salt. In those cases iron 2 is stable. Other than that, iron 3 plus is more common. So during the reaction in situ, this Fe3 iron Br3 is produced. If you take this iron in catalytic amount, so catalytic amount of FeBr3 will be produced, and that iron 3 plus center will act as Lewis acid and participate in aromatic electrophilic substitution. Actually these will react with bromine and produce this bromine plus FeBr4 minus species. It is very reactive because positive charge on bromine is not stable, and actually bromine is carrying positive charge. Positive charge means electron deficiency, means this bromine plus act as electrophile, and these electrophile replaces any one of the proton. 4 protons are equivalent, and it produces this monobromo derivative, and obviously along with this product HBr, means one equivalent of HBr is produced. Okay, so in this way this is actually the product. Now which one is the starting? Option D. Now as I told that I'll teach back calculation. Actually you have to follow this strategy in the exam hall. So I told just from C8, this is C8, and KMnO4 side chain oxidation, it must be carboxylic acid. Okay, now in this case if you look at option A, not possible. It will be C7 carboxylic, means benzoic acid. So this is gone. Now your competition is between B, C and D. By the way, if you look at, these are xylene derivative, orthoxylene, metaxylene and paraxylene. So which one will be oxidized. Now if you oxidize, ultimately what will you get? In this case you will get this phthalic acid, second one will get isophthalic acid, and the third one will result tetraphthalic acid. Now if you want to do the bromination, see, with respect to this dicarboxylic acid, it has two kinds of position. It is symmetrical, I agree. One kind of position here, bromination is meta with respect to this carboxylic acid, and if you consider this carboxylic acid, this is meta with respect to this. So two things same for this is similar with respect to this. So here two bromo product could be possible. If you look at here, so here position 1 type, 2 type, 3 type. By the way, if you say this one and this one same, okay, so it doesn't matter. So it's a 3 bromo derivative preparation possible, and I've explained here only 1 bromo derivative possible. Here also how many if you take, but it is initially cancelled because C7 carboxylic acid, so it's gone. So from there you can get the right answer very fast. Okay student, so I suggest follow this strategy. Whenever you observe the option, in your mind you have to do, this is carboxylic acid, this is carboxylic acid. Okay, so this will be carboxylic acid. So how many position? Only 4 are same position, symmetrical. Here 3 positions, here 2 position, so only D is the right answer. So if you can follow this strategy, you can even less than 10 seconds you can select the right answer. It's a very easy from that perspective. Okay, so this is the overall discussion. I believe this video will be useful. Thanks for watching. See you in my next video. Bye bye.